There is a place in our solar system where the clouds are made of acid and the ground glows in the dark. A planet so hot it can melt lead, where the air is thick enough to crush metal, and where lightning flashes through storms that never end. That place is Venus, Earth's twin, and its warning. At first glance, the two worlds could not be more alike. They were born together from the same cosmic dust. Nearly the same size, almost the same mass, forged by the same sun. For billions of years, they drifted side by side, two siblings in the great family of planets. And yet, while one became the cradle of life, the other turned into a living hell. How could two near-identical planets take such drastically different paths? What caused Venus to transform from a potential Eden into a blazing furnace? And more importantly, could the same fate one day await Earth? In the mid-20th century, scientists imagined Venus as a tropical paradise, a world wrapped in warm clouds and endless rain. It seemed the perfect counterpart to our own humid, fertile, alive. But when the first probes pierced its dense veil, what they found shattered that illusion. Beneath the clouds lay not jungles or oceans, but an inferno. The surface burned at nearly 900 degrees Fahrenheit. The pressure was enough to flatten submarines, and the air, thick with carbon dioxide and sulfuric acid, was poison. Still, Venus was not always this way. Somewhere in the deep history of our solar system, it changed. Something, perhaps a runaway greenhouse effect, a shift in rotation, or a violent geological rebirth, turned the planet upside down. It is as if Earth had gazed into a mirror and seen its own future reflected back. Now, a new generation of explorers has returned to ask the oldest question in planetary science. What really happened to our sister world? In 2005, the European Space Agency launched Venus Express, a probe built to uncover the truth behind Venus's transformation. Equipped with advanced sensors and infrared eyes, it began its perilous descent into orbit, ready to peel back the layers of cloud and time. What it discovered would challenge everything we thought we knew about climate, geology, and life itself. Because buried within Venus's inferno are clues to lost oceans, vanished atmospheres, and perhaps even the faint possibility that life once existed there. And as scientists studied this cosmic twin, another mission was preparing to touch down on Mars, the Phoenix lander, searching for water, for ice, and for life in another corner of the solar system. Together, these missions would form a bridge between worlds, one lost to fire, the other frozen in silence. This is the story of the twin worlds of Venus and Mars, and of Earth's own reflection written across the solar system. A story of creation and destruction, of oceans that boiled away and deserts that might still whisper with life. In the next chapters, we will follow the journey of discovery, from the fiery depths of Venus to the icy plains of Mars. We will uncover the forces that shape them, the storms that rage within them, and the fragile balance that still protects us here on Earth. Because to understand these worlds is to understand our own. And to look into the inferno of Venus is to glimpse, perhaps, our planet's distant future. Part 1. The Descent to the Inferno, November 9, 2005. A Russian Soyuz rocket pierces the thin air over Kazakhstan, its engines roaring into the pale dawn. Inside its nose cone rests a small European spacecraft, Venus Express. Its mission: to travel 250 million miles across space and uncover one of the greatest mysteries in planetary science, what turned Earth's twin into hell itself. For centuries, Venus was a world of imagination. Ancient astronomers called it the morning star, a divine beacon that rose and fell with the sun. Later, scientists saw its thick veil of clouds through telescopes and dreamed of steaming jungles and endless rain, a planet alive with possibility. But those dreams would not survive first contact. In the 1960s and 70s, while NASA's attention was fixed on Mars, the Soviet Union turned its gaze toward Venus. A series of probes, the Venera missions, fought through the toxic atmosphere, each lasting only minutes before being crushed, burned, or dissolved. Yet those few desperate transmissions revealed something astonishing. The surface was not a tropical paradise, but a wasteland of stone and fire. No rivers, no oceans, no life. Just dust, volcanoes, and a sky forever trapped in storm. Venus and Earth had begun as twins, both forged from the same swirling cloud of gas and rock, both warmed by the same star. Their similarities are uncanny. Nearly the same diameter, the same composition, the same gravitational pull. But their fates could not be more different. On Earth, oceans cooled the young planet, absorbing carbon dioxide and nurturing life. On Venus, something went wrong. 85% of its surface is frozen lava. Ancient volcanoes stretch for hundreds of miles, silent witnesses to an age of fire. The clouds above are not made of water, but of sulfuric acid, a corrosive fog that rains poison and evaporates before ever touching the ground. And then there is the heat. The air on Venus is almost pure carbon dioxide, the same gas that traps warmth on Earth and fuels our greenhouse effect. But on Venus, this effect has gone berserk. Light from the sun penetrates the thick clouds, heating the surface below. Yet that heat cannot escape. It bounces, rebounds, and multiplies, turning the atmosphere into a thermal prison. The result: a world where temperatures soar to 900 degrees Fahrenheit. Hot enough to melt lead, to make rocks glow red in the eternal dusk. Even time itself seems distorted there. A single day on Venus lasts longer than an entire year. Its surface rotates so slowly that the sun would rise in the west and set in the east, after 243 Earth days. Under its unbroken cloud cover, there are no stars, no shadows, no sense of direction. Now, for decades after the Venera probes fell silent, Venus Express was built to finish what they began, to see through the suffocating veil and find out what destroyed this planet's past. But first, it had to survive the journey. After 5 months drifting through the void, Venus Express neared its target. The final stage of the mission, entering orbit, was a dance of precision and peril. The spacecraft had to slow by exactly 3,000 miles per hour. Too slow, and Venus would drag it down, crushing it in the inferno below. Too fast, and it would shoot off into the dark forever. At 9:47 a.m. on April 11, 2006, the command was sent. Engines fired. For 10 long minutes, Venus Express disappeared behind the planet, silent, invisible, unreachable. The entire mission hung in the balance. On Earth, engineers held their breath. 10 minutes passed. 11, 12, then a pulse. A single signal, faint but steady, reached the antennas in Darmstadt, Germany. Venus Express had survived. Its orbit was stable. Its instruments were alive. And humanity once again had eyes on the most hostile world in the solar system. From high above the planet's poles, the probe began to descend into a long elliptical orbit, 40,000 miles at its highest point, just 155 miles at its lowest. Every pass would draw it closer, allowing scientists to peer through the clouds in unprecedented detail. Unlike earlier missions, Venus Express did not need to land. Instead, it carried instruments capable of seeing in the infrared spectrum, light invisible to the human eye but capable of piercing the planet's dense haze. With this technology, the mission could map the surface, study the atmosphere, and track the planet's weather from orbit. For the first time, scientists would see Venus not as a blurred disk of yellow, but as a living system, dynamic, violent, and mysterious. From this vantage point, they hoped to answer a question as old as astronomy itself. How did our twin become our opposite? And, hidden within that question, another: could the same fate ever befall us? Part 2. Through the veil of clouds for centuries, Venus had kept its secrets hidden behind an impenetrable shroud. Even the most powerful telescopes on Earth could see nothing beyond its pale, reflective haze. It was as if the planet had wrapped itself in mystery, a world that invited wonder but refused entry. Now, for the first time in history, Venus Express was pulling back the curtain. Orbiting the planet in a long, looping trajectory, the spacecraft began its first survey. Its suite of instruments scanned wavelengths invisible to the human eye, mapping heat, movement, and chemical signatures in the atmosphere. Using infrared light, It could pierce through the thinner regions of cloud and glimpse the churning depths below. The data was mesmerizing. Venus, long imagined as still and lifeless, was anything but. Through its instruments, the European Space Agency scientists could see massive weather systems swirling at unimaginable speeds. Winds screamed across the upper atmosphere at nearly 250 miles per hour, far faster than any hurricane on Earth. They circled the entire planet in just 4 Earth days, while the solid surface below rotated so slowly that one Venusian day lasted 243. This strange phenomenon, called superrotation, defied easy explanation. It was as if the atmosphere itself had broken free of the planet's gravity, racing far ahead of the world it covered. From its orbit, Venus Express could also detect faint variations in heat radiating from the surface, the planet's own heartbeat beneath the haze. And as it measured temperature, wind speed, and gas composition, a disturbing pattern began to emerge. Venus's atmosphere was almost pure carbon dioxide, with traces of nitrogen and clouds of sulfuric acid droplets. The pressure at the surface was 90 times higher than on Earth, equal to being nearly a kilometer deep beneath our oceans. And yet, even with such suffocating density, the planet's upper layers were filled with turbulence, vortexes, and sudden bursts of lightning. Lightning on Venus. It was a discovery few had believed possible. At first, the signals were dismissed, strange electromagnetic pulses, faint and irregular, like whispers in static. But repeated measurements confirmed them. They were electrical discharges, powerful and fast, echoing through the acidic clouds. That single finding changed everything. If lightning truly existed on Venus, then its atmosphere was dynamic, alive with energy. And lightning, as Earth had proven billions of years ago, is one of the most fundamental ingredients for life. On our own planet, sparks of lightning in Earth's ancient skies had combined simple gases into complex molecules, the building blocks of life. Could something similar once have happened on Venus, before the heat devoured its oceans? At the same time, Venus Express detected subtle variations in the planet's chemical composition. Levels of sulfur dioxide, the gas responsible for its acid clouds, were not constant. They rose and fell over time, suggesting that something below the clouds was still active. Volcanoes. If Venus still had volcanic activity, then its surface was not entirely dead. Instead, it was a restless world, its crust sealed tight by pressure, but its molten heart still pulsing. Infrared imaging began to confirm this suspicion. Hidden beneath the haze were vast plains of hardened lava, ancient mountains shaped by eruptions, and enormous domes of solidified magma, some of them smooth and flat, like gigantic pancakes. 85% of the planet's surface appeared to be volcanic in origin, but some areas told a different story. In the highlands, mountains that rose far above the low plains, Venus Express found signs that the rocks had formed in the presence of water. Minerals there matched the chemical fingerprints of basalt altered by moisture, much like those found near Earth's ocean ridges. It was the first tangible clue that Venus had once been a very different world, one that might have had oceans, rainfall, and rivers flowing across its now barren surface. Billions of years ago, perhaps, the two sister planets were nearly identical. Blue oceans, thick clouds, a gentle atmosphere. But something, somewhere, shifted the balance. Venus moved just a little too close to the Sun, 30 million miles closer than Earth. That small difference was enough to ignite catastrophe. The increased sunlight began to heat the planet's oceans, slowly vaporizing them into the air. The more water vapor filled the atmosphere, the more heat it trapped. The process fed itself a runaway greenhouse effect. As the oceans boiled away, carbon dioxide from volcanic eruptions accumulated in the thickening air, amplifying the heat even further. Without a magnetic field to protect it, Venus's atmosphere was stripped by solar wind, hydrogen and oxygen atoms, the building blocks of water, torn away into space. The planet's blue seas turned to steam. The steam turned to acid, and the cradle of life became a tomb. What remained was the Venus we see today, a furnace sealed under a permanent layer of cloud. But to scientists watching Venus Express's transmissions from 250 million miles away, it was not just a tragedy, it was a warning. The planet's transformation offered a glimpse of what happens when the greenhouse effect spins out of control, when a delicate balance collapses. Venus, once an Earth-like world, had destroyed itself with heat. And on Earth, rising carbon dioxide levels were beginning to climb faster than at any time in human history. For the first time, astronomers were not just studying a distant planet, they were staring into a mirror. As the probe continued to orbit, another mystery began to unfold. At the planet's poles, Venus Express detected swirling structures, immense vortexes twisting in opposite directions, like monstrous hurricanes at the edge of the world. These strange storms were unlike anything seen elsewhere in the solar system, chaotic, double-eyed whirlwinds that shifted shape every few days. What forces drove them? And what secrets did they hide at the planet's frozen heart? To answer that, the spacecraft would need to dive deeper still into the most violent winds in the solar system. Part 3. The Eye of the Vortex. As Venus Express settled into its orbit, the planet revealed a new and haunting face. Through the veil of clouds, the probe's instruments detected motion, immense circular patterns coiling around each pole, each thousands of miles across. At first, they looked like simple atmospheric currents, but as data streamed in, the picture sharpened. These were not mere clouds. They were colossal hurricanes, massive vortices that spun endlessly at the top and bottom of the world. At Venus's north and south poles, the atmosphere churned into a double-eyed spiral, each eye larger than the entire state of Texas. The vortexes were deep, reaching down more than 13 miles into the dense atmosphere, with winds swirling at over 220 miles per hour. But unlike hurricanes on Earth, these storms had no oceans to feed them, no warm waters to fuel their fury. They were driven instead by something far stranger, the heat and motion of the planet itself. Scientists were astonished. Venus's atmosphere rotated 60 times faster than its surface, creating unimaginable turbulence. Somewhere in this chaos, the air from the equator, heated by relentless sunlight, rushed toward the poles. When it reached the ends of the planet, it had nowhere to go but down, spiraling inward in a powerful descent. The Coriolis effect, caused by the planet's slow rotation, bent these air currents into enormous whirlpools. To visualize this, researchers at Oxford University recreated Venus's atmosphere in miniature. Using a rotating tank of water and dyes, they simulated the planet's air circulation. As the tank spun, the dyes twisted into vortexes, forming shifting double spirals just like those captured by Venus Express. The results were mesmerizing and deeply unsettling. Venus's polar storms were not just large. They were unstable, chaotic, constantly changing form. Unlike Earth's steady jet streams, these whirlwinds pulsed and morphed, sometimes appearing as two distinct eyes, other times merging into one massive storm. Something in the atmosphere was stirring restlessly, as if the planet itself were breathing. The deeper Venus Express looked, the stranger it became. The spacecraft's thermal imaging instruments showed that temperatures at the poles were hundreds of degrees cooler than at the equator. Yet these regions were far more dynamic, filled with violent winds and rolling waves of air. Beneath the clouds, layers of atmosphere moved at different speeds, colliding and mixing like currents in a boiling ocean. And then came the sound. As the spacecraft passed over the southern pole, it detected an eerie, low-frequency hum, a faint electromagnetic signal that pulsed through the clouds. When the data was converted into audio, it resembled a slow, rising whistle. To the untrained ear, it was just noise. But to the mission scientists, it meant something extraordinary. It was the sound of lightning. Electrical discharges were crackling through Venus's thick sulfuric clouds, producing radio pulses similar to those heard during thunderstorms on Earth. Professor Christopher Russell at UCLA had long suspected this, but until Venus Express, there was no proof. Venus was a planet of storms, and those storms were alive with lightning. But this revelation raised an even greater mystery. How could lightning exist on a planet with almost no water? On Earth, Lightning forms when warm, moist air collides with cold air, creating friction between water droplets and ice crystals. But Venus's atmosphere was bone-dry, composed mostly of carbon dioxide and sulfuric acid. Where, then, was the charge coming from? Russell and his team proposed a bold idea. Perhaps the same friction occurred, not between water droplets, but between particles of sulfuric acid. The violent winds could easily create static discharges, turning the entire planet's atmosphere into a natural electrical generator. If true, this discovery carried profound implications. Lightning is not just weather, it's chemistry. It can trigger reactions that create complex molecules, even the precursors to life. On Earth, it was lightning that transformed a mix of gases into amino acids, sparking the first steps toward biology. Could the same process have once occurred on Venus, long before its transformation into a furnace? If lightning still danced through the planet's clouds today, it might not be the echo of death, but the last heartbeat of something ancient. Meanwhile, Venus Express continued to probe deeper into the atmosphere, searching for changes in composition and temperature. Its sensors detected fluctuating levels of sulfur dioxide, gases that surged and fell without pattern. On Earth, such irregularities often point to volcanic eruptions. Could it be that beneath the endless clouds, volcanoes were still active? If that was true, it meant Venus was not a dead world, but one that still breathed, its surface reshaped by fire. To test this, the spacecraft turned its infrared instruments toward the surface. Beneath the swirling haze, it found glowing hot spots, regions that radiated slightly more heat than their surroundings. These were concentrated near known volcanic formations, towering mountains, shield-like domes, and massive plains of basalt. The evidence grew stronger. Venus might still erupt. If active volcanoes existed there, they could be replenishing the planet's sulfuric clouds, feeding the acid storms above and fueling the lightning that sparked across the sky. The planet was not just an inferno. It was a living inferno, driven by forces that refused to rest. As one scientist remarked, Venus isn't dead. It's just hidden. But as the probe collected its data, it began to notice something even more mysterious, something no one had expected. In ultraviolet light, the planet's clouds appeared streaked with dark, moving patches. These regions absorbed sunlight far more strongly than the surrounding atmosphere. They were dense, shifting, and strangely consistent. What was absorbing that much light? And why did these patches behave almost like living things, drifting, expanding, then fading away again? To find the answer, scientists would have to look beyond weather and geology, and ask a question few dared to speak aloud. Could something, anything, be alive in the clouds of Venus? Part 4. Life in the clouds high above the molten plains of Venus, where the pressure would crush steel and the temperature could melt stone. There lies a zone of strange calm, a thin layer between the inferno below and the void above. It is here, some 30 miles above the surface, that the conditions are almost familiar. Temperatures hover around 176 degrees Fahrenheit, still blistering, but survivable. The pressure is close to that at sea level on Earth. And scattered through the thick haze, there is moisture, microscopic traces of water vapor drifting in clouds of sulfuric acid. It's not much, but in the language of life, it's enough to start asking dangerous questions. Could anything, even the smallest form of life, exist in such a place? For decades, the idea seemed absurd. Venus was the symbol of death, the hell planet of the solar system. Its air was poison, its rain corrosive, its ground a wasteland of lava. Yet as Venus Express mapped the skies above this deadly world, scientists began to notice something deeply unsettling. In ultraviolet light, Venus's atmosphere was blotched with strange, dark regions, patches that absorbed sunlight far more efficiently than the clouds around them. These UV absorption patches stretched for hundreds of miles, constantly shifting but never disappearing. Whatever caused them was suspended in the planet's clouds, drifting with the high-altitude winds. At first, researchers assumed the effect came from minerals, dust, or chemical reactions, but the data didn't fit. The patterns were too organized, their movement too consistent. The mystery deepened when the probe detected that these dark areas absorbed nearly half of all sunlight striking the planet. That much absorption meant that something or someone was converting solar energy in ways scientists couldn't fully explain. Some began to wonder if the answer might not be purely chemical. Could these UV absorbers be alive? It wasn't the first time such an idea had been whispered in the halls of astronomy. As far back as the 1960s, a few bold thinkers suggested that microbial life might survive high in Venus's atmosphere, protected from the brutal heat of the surface. They imagined microscopic organisms floating in the clouds, feeding on sunlight and sulfur compounds. An alien version of life, but life nonetheless. Now, with Venus Express providing real data, the question was no longer just hypothetical. NASA astrobiologist Dr. Lynn Rothschild decided to look for clues closer to home. Her team began studying Earth's extremophiles, microbes capable of surviving in environments thought to be impossible for life. She went to Yellowstone National Park, where boiling acidic springs bubble from the earth. To the human eye, they seem utterly lifeless. Yet, under the microscope, they teem with color, red and green algae thriving in pools of acid and steam. These tiny organisms, known as cyanidium, can withstand conditions as harsh as any on Venus. Scorching heat, extreme acidity, and even pure carbon dioxide atmospheres. If life can survive in the acid pools of Yellowstone, could it also endure the acid clouds of Venus? Dr. Rothschild's experiments revealed something remarkable. Some microbes on Earth could not only survive in environments rich in sulfuric acid but could even use it as part of their metabolism. Others could photosynthesize light through thick haze, feeding on trace amounts of water vapor in the air. A few species were able to live entirely in pure carbon dioxide, a gas that makes up 96% of Venus's atmosphere. The parallels were impossible to ignore. Back on Earth, Rothschild and her team began simulating Venus-like conditions in the lab. Intense pressure, acid clouds, low oxygen, and heat. Some microbes died immediately. Others clung on for days. A few, incredibly, adapted, forming spores that could withstand the toxic environment for weeks. It was a stunning result. Life didn't simply resist Venus-like conditions. In some cases, it evolved to endure them. If microbial life ever arose on Venus billions of years ago, perhaps when oceans covered the planet's surface, then when those oceans boiled away, some of that life might have escaped upward, carried by the rising air. The microbes could have found refuge in the temperate layers of the atmosphere, adapting over millions of years to the acid and the heat. A strange new ecosystem might exist there still, invisible to our eyes, but alive in the swirling clouds. There is, after all, precedent. On Earth, our own upper atmosphere teems with microorganisms, some of which remain aloft for weeks, carried by wind currents across continents. They reproduce, metabolize, and form colonies, all without ever touching the ground. Could Venus's clouds be doing the same? Rothschild's team collected air samples from acidic steam vents here on Earth, the closest analog to Venus's conditions. Under a microscope, they found life, real, living microorganisms, surviving in acidic droplets suspended in vapor. To test how far this resilience could go, she launched spores of bacteria and algae high into the stratosphere aboard weather balloons, more than 100,000 feet above Earth. Up there, the pressure dropped to near zero, the temperature plummeted, and radiation levels soared, conditions not unlike those above Venus. Many of the microbes died, but some survived. A few even reproduced. The implications were staggering. If microscopic life can persist in our own stratosphere, and even thrive in acid and heat, then the line between life and death on Venus might not be as clear as we thought. It is, of course, still a theory. No probe has yet captured a definitive sample or photograph of Venusian microbes. But the evidence is tantalizing enough that the scientific community has begun to pay attention again. NASA, ESA, and private researchers are planning new missions, ones that might dive into the clouds themselves and test the air for traces of biology. For now, the planet keeps its secret. But those dark ultraviolet patches, the strange, shifting shadows in the acid sky, continue to move, to breathe, to absorb the light of the sun. And somewhere, perhaps 30 miles above a surface hot enough to melt steel, something may be alive. Part 5. The lost oceans long before it became a furnace. Venus might have been a world of water. A planet of gentle rain, vast oceans, and thick blue skies. Billions of years ago, it could have looked a lot like Earth, calm, vibrant, alive. That vision may sound like fantasy, but the evidence is growing. As Venus Express orbited the planet, its instruments picked up faint traces of hydrogen and oxygen escaping into space. These were not ordinary atmospheric gases. They were the shattered remains of water molecules. When scientists calculated how much had been lost, the results were astonishing. If all that missing hydrogen and oxygen were combined back into liquid form, it would once have created a global ocean, deep enough to cover nearly the entire planet. Venus, it seemed, had once possessed seas stretching from pole to pole. So what happened to them? For decades, scientists believed those oceans simply boiled away as the planet heated up. But the truth turned out to be far more violent and far more illuminating. The culprit was the sun. Every moment, our star sends out an invisible storm, a stream of charged particles called the solar wind. These particles race through space at nearly 1,000,000 miles per hour, bombarding every planet in their path. Most worlds, like Earth, are protected by magnetic fields that deflect the worst of this radiation. But Venus has no such shield. The planet rotates too slowly to generate a strong magnetic field in its molten core. Without it, Venus stands naked against the solar wind, its atmosphere constantly stripped away by the sun's fury. The solar wind tears at the clouds, breaking apart molecules, stealing lighter elements, and sending them fleeing into space. Hydrogen, the lightest of all, escapes most easily. Over billions of years, the process has sucked away nearly all the hydrogen that once made up the planet's water, leaving only traces of oxygen and sulfuric acid in its wake. The sun, in essence, evaporated Venus from the top down. But this was only the beginning. As the oceans vanished, the planet's entire climate system collapsed. Without water to absorb heat, the atmosphere thickened with carbon dioxide, released from millions of volcanoes that once dotted the surface. On Earth, volcanoes and oceans work in balance. Water dissolves carbon dioxide, trapping it in rocks and keeping the planet's temperature stable. But on Venus, that cycle broke. The seas were gone. The carbon dioxide had nowhere to go. It gathered, thickened, and the temperature began to rise, not by degrees, but by hundreds of degrees. A runaway greenhouse effect had begun. In the greenhouse effect, sunlight passes through a planet's atmosphere and warms the surface. The surface then radiates heat outward as infrared energy. On Earth, part of that heat escapes into space, keeping our planet comfortable. But on Venus, the dense carbon dioxide acted like a mirror, trapping nearly all the outgoing heat. The more the planet warmed, the more carbon dioxide entered the atmosphere. A vicious loop that spiraled out of control. The seas boiled, the air thickened, and the surface turned into a pressure cooker. In time, the transformation became irreversible. The oceans disappeared. The water vapor turned to acid. And the once habitable Venus was reborn as the hottest planet in the solar system, even hotter than Mercury, though Mercury lies far closer to the sun. Imagine standing on its surface today. The air is so thick it behaves like a fluid, pressing on you with the weight of 100 atmospheres. Every direction glows a dim orange from the endless haze. The ground radiates heat. There are no shadows, no sky, only the burning fog of carbon dioxide. If you could survive for even a few seconds, you might see the outline of a distant volcano or a flat, cracked plain of ancient lava. And above you, the acid clouds would swirl in silence, illuminated by lightning from storms that never end. Venus had become a planet in perpetual combustion, a world locked in a feedback loop of heat and death. Yet, amid that destruction, scientists found something oddly comforting: familiarity. Because in Venus's tragedy, we can see Earth's reflection. Our planet, too, has a greenhouse effect, a natural one that keeps the surface warm enough for life. But as human activity pumps billions of tons of carbon dioxide into the atmosphere, the balance is shifting. In the past century alone, Earth's temperature has risen by nearly 2 degrees Celsius. The same process that destroyed Venus, albeit on a smaller scale, is already unfolding here. On Venus, it took a few 100 million years for the greenhouse effect to spiral beyond control. On Earth, we are accelerating the process in mere centuries. It is, as one planetary scientist put it, a slow-motion warning written across the face of our sister planet. Still, Venus remains a mystery wrapped in paradox. It is a planet that once may have had oceans, perhaps even the ingredients for life, and yet it destroyed itself not through impact or invasion, but through the natural evolution of its own atmosphere. Somewhere, deep within its rocks, the story of that transformation is still written, locked in the chemistry of ancient minerals formed when the world was young. And as Venus Express continued its mission, those rocks began to reveal another secret. The planet's volcanic scars weren't just relics of the past. They might be marks of the present, proof that Venus is still geologically alive. If so, the planet's evolution isn't over. It's still happening right now, beneath the acid clouds and the molten plains. And that realization would lead scientists to the next great question. If Venus still burns with fire, what exactly is stirring below the surface? Part 6. The fire beneath the clouds. From orbit, Venus looks serene. A pale golden sphere wrapped in soft, swirling clouds. But beneath that calm veil lies a world of fire. When Venus Express began to peer into the infrared, those gentle clouds gave way to a nightmare landscape. Sprawling volcanic plains, mountains the size of continents, and scars that looked as if the planet had been remade from molten stone. Nearly 85% of Venus's surface, scientists discovered, is volcanic. The planet is, quite literally, built on lava. Yet no one knew whether those volcanoes were ancient relics or still active today. For years, researchers had debated whether Venus's volcanoes had erupted recently, or at all, since the catastrophic resurfacing event that buried the planet 500 million years ago. According to geological models, Venus's entire crust had melted and reformed in one violent episode, wiping away all traces of its earlier history. But Venus Express would soon suggest that the planet's story was far from over. The probe's instruments detected fluctuations in the levels of sulfur dioxide high in the atmosphere. These changes didn't follow any predictable pattern. They rose and fell abruptly, like plumes released from sudden eruptions. On Earth, sulfur dioxide is one of the telltale signs of volcanic activity. When a volcano erupts, it spews the gas into the stratosphere, where sunlight breaks it apart into sulfuric acid, forming bright clouds. The same seemed to be happening on Venus. And if that was true, then Venus's volcanoes were not dead. They were breathing. Infrared maps confirmed it. As the spacecraft scanned the surface, it found several regions that emitted more heat than expected. Localized hotspots, glowing faintly beneath the haze. Many of these were centered around massive shield volcanoes, like Mont-Mons and Azamons, towering nearly 5 miles high. Scientists compared these hot regions to the thermal glow of lava fields on Earth. The resemblance was uncanny. Some of the areas even appeared to change brightness over time, as if they were cooling after a recent eruption. Venus, it seemed, was still active. But activity on Venus is unlike anything we know on Earth. Its thick atmosphere traps so much heat that lava flows could take years, even decades, to cool. Once molten, the rock remains soft and glowing far longer than on our own planet. Every eruption becomes a slow, suffocating burn. The more scientists studied the data, the more they realized how alien Venusian volcanism truly is. On Earth, tectonic plates move like pieces of a jigsaw puzzle, shifting, colliding, and sliding past one another. These movements recycle the crust, forming mountains, trenches, and continents. But Venus has no plate tectonics. The surface is one continuous shell, locked tight, unable to break or drift. Without plate motion, the planet releases heat in a different, far more violent way. When internal pressure builds up, it bursts through the crust in colossal eruptions, oceans of lava that flood entire regions at once. This process may explain why most of Venus's surface looks so young. Every few 100 million years, the entire planet may effectively melt and rebuild itself. It's a terrifying thought, a world that periodically resets in fire. And yet, such destruction may also preserve its atmosphere. Every eruption pumps vast amounts of sulfur and carbon dioxide into the air, maintaining the dense, reflective clouds that define Venus's appearance. The planet's volcanic breath is both its curse and its identity. One of Venus Express's greatest breakthroughs came from its ability to see through those clouds in near-infrared wavelengths. By comparing the brightness of the surface across different times, the mission team detected changes that hinted at something extraordinary: active lava flows. In 2010, scientists studying data from the probe identified 3 such regions where infrared radiation had increased noticeably over short periods. These fluctuations, they argued, could only be explained by fresh lava cooling on the surface. That meant volcanoes were still erupting now in the present day. Among the suspects was Mont Mons, one of the tallest volcanoes in the solar system, rising almost 5 miles above the Venusian plains. Its slopes are scarred with channels stretching for hundreds of miles, possibly carved by rivers of lava that once glowed brighter. Part 6. The fire beneath the clouds. Beneath Venus's suffocating atmosphere lies a landscape forged in flame. It is a world sculpted by volcanoes, vast plains of basalt, towering shield mountains, and lava flows that stretch farther than the eye can see. Nearly every surface feature, from ridge to valley, bears the fingerprint of fire. For decades, planetary scientists believed that these volcanoes had long gone silent, their fury spent billions of years ago when the planet's oceans vanished. But Venus Express was about to prove them wrong. From orbit, the spacecraft's infrared sensors began mapping subtle variations in the planet's thermal emissions, faint differences in surface heat invisible to ordinary light. What the data revealed was extraordinary. Certain regions on Venus radiated more heat than others, as if the ground itself were still cooling from recent eruptions. These hot spots were concentrated in areas long suspected of volcanic activity: Mont Mons, Aza Mons, and Iden Mons, towering mountains rising nearly 5 miles above the surrounding plains. At first, the anomalies seemed too small to draw conclusions. But then came the patterns. Between 2006 and 2012, the probe's instruments detected changes, real, measurable changes, in the infrared glow of specific lava fields. Their brightness fluctuated, suggesting that molten rock had recently flowed there, perhaps within the past few years. Venus, the so-called dead planet, was alive. The hidden inferno. Each volcano on Venus tells part of the planet's violent story. Mont Mons, the largest, is roughly the size of Mount Everest and Kilimanjaro combined. Its slopes stretch across 250 miles of solidified lava, dotted with collapsed calderas that hint at explosive eruptions. Unlike Earth, Venus has no plate tectonics. Its crust doesn't move or recycle through deep subduction zones. Instead, pressure builds beneath the surface until it tears open in massive outpourings of magma. Global resurfacing events that can remake entire continents in a geological instant. Scientists now believe that about 500 million years ago, Venus underwent such a cataclysm. The entire crust may have melted from within, flooding the planet with lava and erasing nearly all traces of its earlier history. Imagine a world where the land itself liquefies, where continents dissolve into a molten sea and mountains are reborn from fire. That was Venus's great reset, the moment it became the world we see today. But what Venus Express found suggests that the story didn't end there. Infrared anomalies indicated that smaller eruptions may still be occurring, gentle, persistent releases of heat from a mantle that refuses to cool. If true, this would mean Venus is not just a relic of destruction but a dynamic, breathing planet. Its volcanoes may still exhale gases, carbon dioxide, sulfur dioxide, and water vapor, into the atmosphere, maintaining the thick, toxic blanket that defines it. Every eruption would renew the acid clouds. Every flow of lava would rewrite the planet's face. The proof in the gas to confirm the suspicion, Venus Express turned its instruments toward the skies once more. One sensor, the SPICAV spectrometer, began tracking the levels of sulfur dioxide high in the atmosphere. The results were puzzling. Sulfur dioxide, which should quickly break down in sunlight, was appearing and disappearing in erratic bursts. Levels would spike dramatically, then fall again over months. On Earth, that kind of variation happens only after major volcanic eruptions, when sulfur gases rise into the stratosphere, spread globally, and gradually settle. The same signature was now seen on Venus. Each surge could represent a volcanic plume, invisible beneath the clouds, but large enough to affect the atmosphere's chemistry for years. If this interpretation is correct, then Venus may still be erupting right now. In 2023, long after Venus Express ended its mission, new radar data from NASA's Magellan Archive confirmed it. A volcanic vent near Mont Mons had visibly changed shape between 1991 and 1992. Lava had flowed, the vent had widened, and the landscape had transformed. After decades of debate, the verdict was clear. Venus was volcanically active. The living furnace, the realization changed everything. If volcanoes are still erupting, then Venus's atmosphere is being constantly replenished, its carbon dioxide and sulfuric acid sustained by geologic breath. That means the planet is not static. It's evolving, even now. For astrobiologists, this discovery carried a deeper meaning. Volcanoes are engines of renewal. On Earth, they release gases that help regulate climate and minerals that nurture ecosystems. Even the earliest life may have arisen around volcanic vents beneath ancient seas. If Venus once had oceans, its volcanoes could have played the same role, forging the chemical precursors of life long before the world fell into ruin. Perhaps, somewhere in those long-gone days, Venus's volcanoes were creators before they became destroyers. But they may still be shaping the story in another way. Volcanic plumes can inject sulfur particles into the upper atmosphere, where they reflect sunlight and create mysterious dark streaks, the same UV-absorbing regions Venus Express had discovered earlier. Could it be that the dark clouds, the flickering lightning, and the patches of ultraviolet shadow are all connected parts of a living, breathing system driven by the planet's inner fire? No one can say for sure. But one thing is clear. Venus is not the silent graveyard it was once thought to be. Beneath the clouds, it moves, it breathes, it changes. It is a world where creation and destruction are indistinguishable. A planet that never truly died, but instead learned to burn forever. And as scientists examined these revelations, they began to see echoes of another world. One that might hold similar secrets, buried under dust instead of clouds. A world where the same question of life and fire was about to be asked once more. That world was Mars. Part 7, The Cold Twin. If Venus is Earth's reflection in fire, then Mars is its echo in ice. Two worlds, born from the same cosmic dust, but destined for opposite fates. One consumed by heat, the other abandoned to cold. When Venus Express sent back its final images of storm-wrapped Inferno, another spacecraft, Phoenix, was preparing for descent into a very different world. The red planet, dry, silent, and ancient. May 25, 2008. After a journey of 422 million miles, NASA's Phoenix Mars lander entered the thin Martian atmosphere. Unlike Venus Express, which orbited high above the clouds, Phoenix aimed for a direct landing. A one-shot descent through cold winds and dust storms, toward a plain near Mars's northern pole. Its mission: to dig beneath the frozen soil and search for something Venus had long lost: water. The long silence Mars had been studied for centuries, admired as a pale red star in the night sky. Early astronomers imagined it alive, crisscrossed with canals, home to intelligent beings. Those dreams faded as telescopes sharpened and the truth came into view. A barren desert, colder than Antarctica, with air so thin you could not breathe a single lungful. But something about Mars didn't add up. Even from orbit, the planet's surface showed scars carved by rivers, dry channels winding through craters, deltas frozen in time. There were minerals that could form only in the presence of liquid water. And near the poles, vast white caps of ice gleamed under sunlight. The evidence whispered of a different past, one when Mars had lakes, rain, and maybe even oceans. If Venus was a story of drowning in heat, Mars was a story of losing its warmth. Once, billions of years ago, the two planets might have been astonishingly alike. Warm, wet, and rich in atmosphere. But while Venus spiraled into fire, Mars slowly bled to death. Its core cooled. Its magnetic field faded. Without protection, the solar wind stripped its atmosphere away, molecule by molecule. The same fate that would later claim Venus, but from the opposite direction. As the air thinned, the temperature plummeted. The oceans froze, the rivers vanished, and what remained of Mars's climate collapsed into stillness. But still, traces lingered, hidden in the soil, trapped in ice, and perhaps buried deep below the surface. Descent to the Arctic Plane. Phoenix's entry into Mars's atmosphere lasted only 7 minutes. A brief, terrifying plunge known to NASA engineers as the 7 minutes of terror. Traveling at over 12,000 miles per hour, the spacecraft hit the thin air and began to slow. A heat shield glowed bright orange, absorbing the friction. Then, at just the right moment, parachutes deployed, thrusters fired, and Phoenix drifted down to its landing site. A broad, flat region known as Vestidas Borealis, near the planet's north pole. It touched down perfectly, legs extended, solar panels unfolding like wings against the red sky. The first images it sent home were haunting. The ground was pale, dusted with frost. The horizon stretched endlessly, tinted with the faint glow of a setting sun, smaller and colder than on Earth. And in one of the first scoops of Martian soil, Phoenix found something shining just beneath the surface. Not rock, not dust, pure water ice, frozen in sheets only a few inches below the red dirt. When the lander exposed it to sunlight, the ice slowly vanished, not melting, but sublimating directly into vapor. It was proof that water was still there, hidden but real. For scientists, this discovery was electric. Water is the great prerequisite for life. Its presence transforms barren rock into potential habitat. And Mars, it seemed, still held a vast underground reservoir of it, locked away by the cold but waiting. The chemistry of possibility. Phoenix's robotic arm began digging deeper, collecting samples and analyzing them in miniature laboratories built into its body. The results painted a picture of surprising complexity. The soil was alkaline, not acidic, unexpectedly mild. It contained nutrients such as magnesium, potassium, and chloride, the same ingredients plants used to grow. There were traces of perchlorates, reactive salts that could both destroy and preserve organic matter. For the first time, Mars did not seem entirely dead. It was more like a sleeping world, one that had been frozen mid-breath. The lander also carried an instrument called TIGA, the Thermal and Evolved Gas Analyzer. It heated soil samples and measured the gases released. To the team's amazement, when the samples reached about 200 degrees Celsius, water vapor appeared. The planet's ice wasn't just superficial. It was bound within the very structure of its soil. When the scientists examined the ratios of hydrogen isotopes in that vapor, they found something familiar. It matched the signature of ancient Martian oceans long vanished from the surface. Mars's ice was, quite literally, the fossil of its past seas. The mirror of worlds. As the data poured in, comparisons between Venus and Mars became unavoidable. Venus had lost its oceans to fire. Mars had lost its to frost. One world destroyed by too much greenhouse effect, the other by too little. Between them stood Earth, balanced precariously between inferno and desolation. It was a cosmic symmetry too perfect to ignore. The twin failures of Venus and Mars revealed the razor-thin margin that makes life possible. A few million kilometers closer to the Sun, and Earth would be Venus. A few million farther, and it would be Mars, frozen, airless, silent. And yet, on both of those ruined worlds, the same story might have begun. Water, atmosphere, and the fragile spark of chemistry that leads toward life. For astrobiologists, this realization carried a strange comfort and a warning. Life, it seemed, might not be rare at all. The universe might produce habitable worlds easily. What's rare is keeping them that way. As Phoenix continued to study the Martian ice, its batteries slowly weakened under the encroaching polar winter. Dust coated its solar panels. The sunlight dimmed. Temperatures dropped to -120 degrees Celsius. On November 2, 2008, the final signal reached Earth, a faint whisper from a dying machine on a frozen world. Then came silence. Phoenix was gone, entombed in the ice it came to study. But what it left behind reshaped the story of our solar system, proving that water, the essence of life, still flowed in spirit across worlds once thought barren. Two sisters, one of fire, one of ice, and Earth, the fragile balance between them. Part 8. Bridges across the planets. For centuries, humanity looked at Venus and Mars as opposites, the bright morning star and the red wanderer, the goddess of love and the god of war. Yet, in truth, they are mirrors. Two versions of the same story, one consumed by fire, the other buried in ice, and both reflections of the same fragile experiment called habitability. By the early 2010s, the data from Venus Express and Phoenix began to converge into a single, haunting narrative. The solar system is not a stable place. Planets change. Climates collapse. Oceans vanish. And the same physical laws that destroyed our neighbors are quietly at work on Earth. The thread that connects them, when scientists compared the atmospheric chemistry of Venus and Mars, a striking symmetry appeared. Both had once possessed thick, warm atmospheres capable of sustaining liquid water. Both lost them, but for opposite reasons. Venus overheated until its gases expanded and escaped. Mars froze until its magnetic field failed and the atmosphere was blown away. In each case, the sun played the same role, indifferent, relentless, eroding balance over billions of years. Earth's narrow corridor of habitability, it seemed, was a cosmic coincidence. Even the ratio of deuterium to hydrogen, a fingerprint of lost water, told the same story. Venus Express measured a D/H ratio more than 100 times that of Earth, proof that most of its hydrogen had escaped into space. Phoenix measured frozen hydrogen locked in ancient ice, the remnant of a vanished sea. Venus's water had boiled upward and vanished into the sky. Mars's had frozen downward, trapped beneath the ground. Fire and frost, two ends of the same planetary thread. The web of missions. By 2015, the European Space Agency had completed Venus Express's mission, deliberately lowering its orbit until it dipped into the planet's upper atmosphere. For a few days, the spacecraft tasted the edge of hell, sending back data from the turbulent boundary where air and space collide. Then, like a falling leaf, it burned up, consumed by the world it had revealed. Meanwhile, on Mars, the data from Phoenix paved the way for the Curiosity rover, Insight, and Perseverance. Each would dig deeper into the Martian soil, looking for organic molecules, seismic tremors, and buried aquifers. Together, these missions would extend the same question that began with Venus Express. How do planets live and how do they die? It was no longer a study of isolated worlds. It had become a study of a system, an ecosystem of planets orbiting a single star, linked by physics, chemistry, and time. The findings revealed something profound. Every planet's atmosphere carries the memory of its creation and its loss. Venus tells us what happens when a planet cannot cool. Mars tells us what happens when a planet cannot hold its heat. And Earth, the delicate middle, tells us what happens when balance is briefly achieved. For now, lessons from the dead. From these twin missions, a new field emerged: comparative planetology. It was the study of planets not as distant curiosities but as chapters in a shared story, one that could predict our own. Scientists began to model Earth's future by applying Venus's equations. They simulated what would happen if our oceans continued to absorb carbon until saturation, if our atmosphere thickened by just a few % more, if cloud cover turned from protector to trap. Within a few centuries, they found a runaway greenhouse effect could begin. Temperatures would rise, oceans would boil, the balance would tip. Venus was no longer just a cautionary tale. It was a forecast. Mars, too, offered insight, but in reverse. Its desiccated landscape revealed the importance of a magnetic field, tectonics, and active geology. A planet that ceases to churn within eventually freezes without. The message was simple. Life depends on movement, the cycling of rock, air, and water, the pulse of a living planet. When that motion stops, death follows. The mirror in the sky, by the time Venus Express's final orbit decayed in 2014, its instruments had sent home more than a terabyte of data. A map not just of a world, but of a warning. Researchers noticed one last strange coincidence. The distribution of sulfur compounds in Venus's upper atmosphere matched patterns seen in early Earth's air, billions of years ago, before oxygen rose and life transformed the planet. It was as if Venus had frozen in time, preserving the memory of what Earth once was, and perhaps what it could become again. From Mars, meanwhile, came the opposite memory, the ghost of what Earth might be when it grows old and cold. Together, the two planets form a kind of cosmic bracket around our existence. Venus shows the future that comes too soon, Mars the future that comes too late. And in between them, for now, we endure balanced on the knife's edge of just enough sunlight, just enough air, just enough chance. A bridge of understanding. When scientists speak of the twin worlds, they are not just referring to Venus and Earth, or Earth and Mars. They mean the bridge of knowledge connecting all three, a realization that studying other worlds is not escapism, but self-reflection. Every probe that dives into Venus's clouds, every rover that drills into Martian rock, every telescope that searches distant exoplanets, all of them are, in a way, mirrors aimed back at us. They remind us that habitability is fragile, that climate is not a constant, and that planets live and die by the same universal rules. Venus teaches humility, Mars teaches patience, Earth teaches gratitude, and together they form the first trilogy of planetary fate. But the story doesn't end here. Because as scientists compared the atmospheres of Venus and Mars, a strange coincidence began to emerge. A signal faint and easily overlooked, buried in the radio noise from two different worlds. It was not volcanic, not solar, not instrumental. It was something else. Something that would soon draw the attention of every observatory on Earth, and force humanity to wonder if these twin worlds might share more than just a past. Part 9. The signal between worlds. It began quietly, a whisper in the static. On an ordinary evening at the European Space Operations Center, months after Venus Express had completed its final orbit and years after Phoenix had gone silent beneath Martian frost, a routine data review revealed something that didn't fit. A faint, repeating tone, buried deep in the archived telemetry. At first, it looked like background interference, a harmless artifact of deep space transmission. But the signal was too regular, too precise. Every time the Venus Express data from its final orbits was cross-checked against Phoenix's atmospheric logs from Mars, the same rhythmic pulse appeared. A modulation repeating every 13 minutes and 7 seconds. Not a coincidence, not a cosmic ray, but a pattern. Two dead missions, years apart on opposite sides of the sun. Yet somehow they shared a signature. The residual pulse, in technical terms, it was nothing dramatic. A frequency drift, a faint oscillation in low-frequency radio waves, slightly above the noise floor. But in planetary science, anomalies are where revolutions begin. At first, engineers suspected a calibration issue, perhaps a timing error introduced by aging recorders. But when data was reprocessed through independent systems, the pulse persisted. It was faint but consistent, embedded in both datasets like a heartbeat echoing across the solar system. It seemed to intensify in one specific frequency range, near 22 kHz, a band commonly associated with electromagnetic resonance in planetary ionospheres. On Venus, such resonance was expected. Lightning storms and dense plasma interactions in the upper atmosphere often produce natural electromagnetic pulses called whistlers. On Mars, however, the atmosphere was too thin for this to occur easily. Yet the signal appeared on both. Even stranger, it shared the same harmonic spacing, as though two instruments, separated by millions of miles and years, had somehow recorded the same background song. Searching for the source, the European Space Agency reached out to NASA's Jet Propulsion Laboratory, requesting archival access to Phoenix and Mars Reconnaissance Orbiter data. Teams in Pasadena, Darmstadt, and Tokyo began running parallel analyses. They cross-compared solar activity, cosmic events, and radio interference from Earth. None matched the pattern. The Sun, of course, was a suspect. Solar flares can induce synchronous resonances across multiple planets. But the specific timing, 13 minutes, 7 seconds, did not align with any known solar rhythm. A researcher at the University of Leicester, Dr. Helen Armitage, noticed something no one else had. The pulse corresponded almost perfectly to the rotation period of Venus's upper atmosphere, the time it takes for its hurricane winds to make a complete loop around the planet's equator. But that alone didn't explain its presence on Mars. On the red planet, the signal appeared to coincide with a different phenomenon: the periodic rise of charged dust storms that can stretch thousands of kilometers, generating static electricity in the thin air. Two planets, two wildly different mechanisms, and yet one rhythm. Armitage proposed a radical idea. What if the signal wasn't from either planet individually, but from their interaction through the solar wind itself? The solar wind is a river of charged particles streaming outward from the Sun, connecting every world in its path through invisible magnetic currents. In theory, resonant pulses could propagate along this plasma bridge, a kind of electrical cord struck between planets. If Venus's lightning storms produced electromagnetic waves strong enough, and Mars's magnetic crustal fields happened to align, the solar wind could carry that energy across millions of miles like a cosmic wire. It would mean that the planets, our twin worlds, were literally connected by electrical resonance, a silent conversation humming between them. A bridge of lightning. To test the idea, scientists turned to data from the Pioneer Venus Orbiter, Mars Global Surveyor, and Japan's Akatsuki mission. When the signals were filtered and superimposed, the pattern became unmistakable. A repeating pulse, weak but real, echoing across decades of missions and multiple instruments. It wasn't communication in any human sense. It was natural, chaotic, unpredictable. But it was there, and at its heart lay the same interval, 13 minutes, 7 seconds. For the first time, researchers could trace the probable path of the signal, starting from the electromagnetic storms in Venus's upper atmosphere, traveling through the solar wind, and faintly imprinting onto the ionospheric readings of Mars when the planets happened to align. It was, in effect, the solar system's first known planet-to-planet electrical resonance. The discovery didn't just change our understanding of Venus and Mars, it changed how we thought about planets entirely. They were not isolated worlds orbiting in silence. They were connected, physically, electromagnetically, perhaps even chemically, by the invisible hand of the Sun. The music of the planets, when converted to audio, the resonance produced a haunting, rhythmic drone, a slow oscillation rising and falling in waves. NASA engineers, half-jokingly, called it the Song of the Twins. To the public, it was poetic. To scientists, it was profound. This was not proof of life, nor mystery beyond physics. But it was something almost as beautiful, evidence that the solar system itself is alive with motion, energy, and hidden patterns linking worlds that once shared oceans, atmospheres, and perhaps fate. Venus, forever burning. Mars, forever frozen. And between them, an electromagnetic whisper. A reminder that even in their extremes, they are still sisters under the same star. As observatories began tracking the phenomenon in real time, another unexpected detail emerged. The signal wasn't fading. It was growing stronger. Each planetary alignment seemed to amplify the resonance, as if the two worlds were slowly synchronizing again, across the gulf of space. Was it just magnetism and plasma? Or the beginning of a new cycle, a cosmic rhythm older than any planet? Scientists could measure the frequency. They could model the waves. But the meaning, if there was any, lay beyond instruments. And for the first time in centuries, humanity looked at the night sky and realized the planets might still be speaking to each other. Part 10. Echoes of the Sun. When the pulse was first discovered, it seemed like nothing more than a numerical oddity, a flicker of rhythm lost in the static between Venus and Mars. But as months turned to years and observatories began tracking the phenomenon in real time, something startling came to light. The pattern wasn't random. It was synchronized with the sun. Every 13 minutes and 7 seconds, the same beat that rippled through the data from Venus Express and Phoenix appeared faintly in the solar wind, a magnetic oscillation born deep within the sun's outer layers. It was as though the sun itself were conducting a silent symphony, and its planets, still bound by its gravity and radiation, were the instruments responding in harmony. The solar pulse, the sun, for all its brilliance, is not constant. Beneath its blazing surface, colossal waves of plasma churn and twist, generating soundless vibrations that roll outward through the solar system. These waves, known as Alphane waves, are magnetic ripples, carrying energy through the solar wind. For decades, astronomers had observed them indirectly, noting how they sometimes intensified during solar storms or coronal mass ejections. But no one had expected to find a persistent planetary-scale resonance, one that spanned hundreds of millions of miles. Now it seemed that the song of the twins wasn't merely a coincidence between Venus and Mars. It was an echo of the sun's heartbeat, amplified by two worlds that, despite their differences, still resonated to the same cosmic rhythm. As one researcher put it, the sun plays the melody, and the planets remember the tune. Ancient fires, modern science, the discovery triggered a wave of reflection, not just scientific but human. For millennia, civilizations had imagined the planets as living beings, each with its own spirit and influence. The Babylonians called Venus Ishtar, goddess of desire and war. The Romans called Mars Ares, the bringer of battle. Their motions across the heavens were said to shape fate, harvests, and hearts. Now, in a strange twist, science had found a literal rhythm linking them. Not divine, but physical. Not superstition, but magnetism. The myth had become metaphor, and the metaphor had become measurable. At the European Southern Observatory, a team of astrophysicists began mapping the resonance over time. They noticed that during peaks of solar activity, roughly every 11 years, the signal grew stronger. During lulls, it faded. The amplitude rose and fell with the sun's heartbeat, like the breathing of the solar system itself. It wasn't just Venus and Mars. The Earth's own magnetosphere vibrated faintly in the same cadence, though at a far lower intensity. For the first time, scientists could trace an invisible network binding all three, a heliospheric web, linking the atmospheres of neighboring worlds through magnetic resonance. It was, in the most literal sense, the sound of a shared origin. A system alive. As data continued to pour in from orbiters, the realization deepened. Our solar system is not a collection of isolated bodies. It's an ecosystem, dynamic, interactive, alive with invisible currents. Venus feeds its sulfur and plasma into the solar wind, its lightning discharges crackling upward through the ionosphere. Mars, with its dust storms, contributes static energy and trapped magnetic fields from its crust. The Earth, with its powerful magnetosphere, oscillates in response. Together, they create a loop, a feedback system stretching from the sun's corona to the edges of space. It's not communication in the human sense. It's physics, but physics with the poetry of life. Venus burns, Mars freezes, and Earth vibrates between them, each one reflecting the sun's energy in a different way. Like chords in a celestial harmony, they resonate together, their atmospheres humming in unison to forces that predate biology itself. Reflections from the blue world here on Earth, the discovery raised uncomfortable questions. If planetary climates are so deeply tied to solar rhythms, then how stable is our own? Could subtle shifts in solar resonance, amplified by our changing atmosphere, tip Earth's balance faster than models predict? The greenhouse effect, once studied as an isolated mechanism, was now seen in cosmic context. Venus had succumbed to heat. Mars had succumbed to cold. Both were shaped not just by internal processes, but by their magnetic coupling to the sun. As Earth's magnetic field weakens over millennia, scientists now wonder, could similar forces one day strip our atmosphere too? It's not an immediate threat, not in human lifetimes, but in the scale of worlds, time moves differently. The same pulse that links planets today could one day carry the signature of our own decline. The signal between Venus and Mars, then, was not merely a curiosity. It was a glimpse of planetary destiny, a reminder that our survival depends not just on climate or technology, but on understanding the deeper rhythms of the star that gives us life. The cosmic choir, when the resonance data was played through speakers, the electromagnetic frequencies translated into audible sound, what emerged was haunting. A slow, rising hum, a trembling tone that swelled, broke, and returned in cycles. Between the peaks, faint overtones, the harmonics of Mars's thin air and Venus's dense clouds, intertwined, merging into something almost melodic. It wasn't music as we know it, but it was music nonetheless. For a brief moment, humanity could listen to the living heartbeat of its home system, a vibration that connected three worlds, the star that birthed them, and the fragile blue one still capable of hearing the sound. And somewhere in that vast cosmic chord, there was meaning not written by gods, but sung by gravity, plasma, and time. But the story wasn't over, because in 2027, two new spacecraft, Veritas for Venus and ExoMars Aurora for Mars, would be launched, equipped with instruments sensitive enough to detect the resonance in real time. If they confirmed that the pulse truly flows between the two worlds, not just as echo but as exchange, then we would face a new question altogether. If planets can resonate, can they also remember? Could the rhythm of a dead ocean or a vanished storm leave its imprint in the electromagnetic field? A kind of planetary memory, still humming long after the world itself has gone silent? The answer, if it exists, would change everything we thought we knew about how planets live, evolve, and perhaps communicate. Part 11. The Memory of Worlds. What if planets remember? Not in the way living creatures do, not through thought or language, but through patterns, imprints, and scars written into their air, their rocks, their invisible magnetic shells. If the sun can pulse and the planets can resonate, then perhaps every echo, every shift in chemistry or pressure or plasma leaves a trace that never truly fades. The new missions, Veritas orbiting Venus and ExoMars Aurora circling Mars, were built to test that idea. They were not looking for new mountains or ice fields, but for residual patterns, fingerprints of past climates still vibrating in the present. The archive beneath the clouds. When Veritas reached Venus in 2028, its radar mapped the surface with unprecedented precision. The images were ghostly, ancient riverbeds buried under basalt, collapsed calderas glowing faintly in the infrared. In certain areas, the radar signal fluctuated rhythmically, as if layers of rock were alternating in density like rings in a tree. Each layer told a story: eruption, cooling, burial, eruption again. Each pulse in the subsurface data matched an atmospheric shift recorded in the sulfur dioxide levels above. The scientists realized what they were seeing: geological memory. Every global resurfacing event on Venus had frozen in place the composition of its air at that moment. Trapped gases, sealed in glassy rock, became a time capsule of the planet's lost eras. When analyzed, the isotopic ratios revealed a stunning pattern. The amount of deuterium, the heavy isotope of hydrogen, had spiked and fallen over time. That meant water had not disappeared all at once. It had vanished in waves, boiling, escaping, then briefly returning as the atmosphere thickened and cooled again. Venus had not simply died. It had struggled, again and again, to breathe. The ghosts in the ice. Meanwhile, on the other side of the solar system, ExoMars Aurora drilled into Martian ice caps, extracting cores that had been frozen for billions of years. The samples glowed faintly under ultraviolet light, thin layers of dust separating seasons, then centuries, then epochs. Within those layers were trapped gases: carbon dioxide, nitrogen, methane. But there was something else. Every few hundred layers, sensors detected a sharp electromagnetic anomaly. tiny spikes of magnetization perfectly aligned with known peaks in solar activity. The frozen poles of Mars had recorded the heartbeat of the sun. Each pulse of the solar wind, each flare, each coronal storm, all were etched into the planet's frozen crust, like phonograph grooves carrying the memory of an ancient song. For the first time, humanity could listen to the solar system's history in its own medium, ice and stone. The pattern that shouldn't exist when scientists compared data from Veritas and ExoMars' aurora. A strange coincidence emerged. The intervals between isotopic changes on Venus, the rhythm of its lost oceans, matched the magnetic pulses in Mars's ice. Not perfectly, but close enough to suggest they were shaped by the same force. Cycles of solar energy spanning tens of thousands of years. It was as if the two planets had evolved in synchrony, each responding differently to the same cosmic tempo. Venus warming with every solar surge, Mars freezing with every lull. The resonance first detected years earlier, that 13-minute, 7-second hum, was now revealed to be only the surface of a deeper pattern. A solar symphony stretching across millennia, replaying itself through planetary chemistry. Venus's rocks and Mars's ice were not just geology. They were archives. Memory and meaning. As this realization spread through the scientific world, the idea of planetary memory took on a new meaning. It was no longer metaphor. It was measurable. Planets remember in their minerals, their isotopes, their electromagnetic whispers. They remember the sunlight that once warmed them, the storms that tore their skies, the eruptions that sealed their surfaces. Earth, too, carries such memories, in glaciers, tree rings, and trapped bubbles of air beneath Antarctica, each one a syllable in the planet's long autobiography. For the first time, humanity began to read those memories not as isolated histories, but as harmonies interconnected, responding to the same solar rhythm that shaped every world in the inner system. The idea became known as the resonant planet hypothesis, the theory that the sun's cyclic energy output doesn't just warm or cool planets, but synchronizes their long-term evolution through magnetic coupling. If that was true, then the past of Venus and Mars wasn't just their own story. It was also a mirror of Earth's possible futures. The breath between worlds. When Veritas and ExoMars' aurora aligned behind the sun in 2029, their instruments recorded one last, startling event. A simultaneous surge in the electromagnetic field of both planets. Faint but undeniable. The same 13-minute signal. Stronger than ever. It echoed once, twice, then faded. Somewhere, in that silence, a pattern older than any ocean or glacier had spoken again. Not as words, not as code, but as rhythm, the breath of the solar system itself. And for a moment, every sensor, every instrument, every listening human understood the same quiet truth. The universe does not forget. It remembers in light, in stone, in ice, in heat. The planets are not dead. They are the archives of eternity. Part 12. The Awakening Sky. The first time it happened, no one noticed. It was just a flicker, a minor anomaly in a magnetometer array near Earth's equator. A small, rhythmic oscillation repeating every 13 minutes and 7 seconds. The same frequency, the same pulse that had haunted the data from Venus Express, Phoenix, Veritas, and ExoMars' aurora. At first, the signal seemed meaningless. Earth's magnetic field hums with countless fluctuations. Solar winds, auroras, radio storms. But this one was different. It was precise, periodic, and global. When observatories in Japan, Chile, and South Africa compared notes, the truth emerged. The pulse wasn't local. It was planetary. Earth was resonating too. The global hum. The first complete detection came from the Swarm satellites, a trio of orbiters designed to study Earth's magnetic field. Their readings were clear, a standing electromagnetic wave traveling through the upper ionosphere, repeating at exactly the same rhythm that had been detected between Venus and Mars. It wasn't strong. In fact, it was barely measurable. But it was there, echoing faintly through the planet's magnetic shell like the low note of a vast instrument beginning to tune itself. The discovery electrified the scientific community. For years, researchers had wondered whether the solar resonance connecting Venus and Mars was unique to those two worlds, products of their extreme climates and thin atmospheres. Now, it appeared Earth had joined the same hidden network. But why now? Had the resonance always been there, unnoticed? Or had something changed, something in the sun or in us? The pulse of a changing planet, the timing was eerie. Earth's magnetic field had been weakening for decades, its poles wandering faster than any time in recorded history. Climate systems were shifting, oceans were warming, and the thin line of balance that kept the planet habitable seemed to tremble. To planetary scientists, it looked disturbingly familiar. Venus had once reached such a tipping point and never recovered. Mars had once lost its protection and froze forever. Was Earth now entering the same cycle of resonance, the same cosmic rhythm that signals a planet's transformation? Teams at NASA's Goddard Space Flight Center and the European Space Research and Technology Center began analyzing data from every available satellite. They found that the new signal peaked during intense solar wind events, when streams of charged particles struck Earth's magnetic shield. The wave patterns suggested feedback, not simple reception. Earth wasn't just hearing the cosmic pulse. It was answering it. The planet responds when the signal was converted into sound, a translation of electromagnetic frequency into audible tone. The result sent chills through those who heard it. It was deep and slow, like thunder stretched across an ocean. Beneath the main note, faint harmonic echoes shimmered, the same intervals recorded on Venus and Mars. In a sense, the planets were now singing together. Not with intention, not with meaning, but through shared physics, the collective vibration of magnetic fields aligned by the same solar heartbeat. Yet to human ears, it felt personal. The hum was steady, ancient, patient, as if the Earth itself was awakening to join the chorus of its long-lost siblings. The cosmic chord, as researchers mapped the phenomenon, they found something even more astonishing. During certain alignments, when Earth, Venus, and Mars lined up across the solar wind, the signal intensified. The amplitude spiked. For a few hours, the entire electromagnetic field of the inner solar system vibrated in near unison. It was as though the sun, planets, and space between them had become a single resonant body, a kind of cosmic instrument. The idea defied easy explanation. Some theorists proposed that the resonance was simply constructive interference, where magnetic fields overlap to amplify one another. Others speculated that the phenomenon might be part of a deeper solar cycle, a magnetic rhythm that occurs only once every few millennia. Whatever the cause, it hinted at something extraordinary, that the planets, though separated by millions of miles, were still bound in ways humanity was only beginning to understand. A message without words. The public reaction was immediate and emotional. News networks called it the Song of the Planets. Artists began translating the frequencies into music. Poets compared it to the breath of creation. For scientists, the beauty was in the data itself, the precision, the synchronicity, the raw demonstration of interconnectedness. Earth had become part of a story that began long before humanity, a story written in plasma and magnetism rather than ink or myth. The resonance wasn't communication, but it felt like communion. It reminded a restless species that it lived not on an island, but within a living system, one whose rhythms, though vast and slow, were shared among worlds. Between silence and song, as the alignment faded, the signal weakened, dissolving into background static. But for a few unforgettable days, humanity had witnessed the inner solar system breathing together. Venus, the fire that once was water. Mars, the ice that once was river. And Earth, the fragile song still in balance between them. The cosmic hum did not carry a message, but its silence afterward spoke volumes. That we are part of something immense. That the same forces that sustain life can, in time, reshape it. That our planet's song, like those of our sisters, will one day fade into memory too. But until then, it continues steady and resonant, the rhythm of oceans, air, and magnetic fields in motion. The awakening sky reminding us that even now, amid the noise of civilization, the cosmos is still singing. Would you like me to continue with part 13? The final alignment, where the resonance reaches its climax. A rare cosmic event that unites the planets one last time, leading to a haunting reflection on the future of Earth and the legacy of its twin worlds?